Welcome to the video on graphing trig functions. So first we'll talk about the basic graphs for sine, cosine, and tangent. So your sine function, your y-intercept is 0, 0. Your amplitude is 1. So your amplitude is the distance from your midline to the top and to the bottom. So that distance is 1. So right here that's 1. And here is -1. Your period is 2 pi, so the period is the amount of time it takes to complete one cycle. So here, your period is 2 pi, so it takes 2 pi to go from the origin, and then it goes up, down, and then back to the origin, and then it'll repeat itself every 2 pi. And then your direction from your starting point is up, so you're going to go up unless it's been reflected. For your cosine function, your y-intercept is 0, 1. So you start at 1. Your amplitude is still 1. So this distance is 1. And this distance is 1. All the way down to here. Your period is 2 pi. So it'll start repeating itself after 2 pi. And then your direction is down. So from your starting point, your y-intercept, you'll go down. For your tangent function, your y-intercept is 0, 0. Your period is pi, so it'll repeat every pi. So from here to here, then it'll repeat itself. Typically, for one period, you'd start with your part where it's down and then go to your part where it's up. From your y-intercept, you're going to go up. And then you'll have vertical asymptotes starting at pi over 2. And then you'll have it every pi from there. So when you add pi, you'll have another vertical asymptote, or if you subtract pi, you'll have another vertical asymptote. So that's how to graph your basic trigonometry functions. So from your basic trig functions, you'll then perform transformations. So this is how those functions can be transformed. You could have it sine, cosine, or tangent. So it doesn't matter which function it is, these different variables will do different things to it. So your a would be a vertical stretch by a factor of a. And a is your amplitude. So if a was 4, for example, your amplitude would be 4. So your function would go from +4 to -4. So for example, with sine, it would go like that. Your b value would be a horizontal stretch by a factor of 1 over b. So what it would do is it would change your period, and you would do 2 pi divided by b. So if your b value was pi, then your period would be 2 pi over pi, which simplifies to 2. So that's how you would figure out what your period is from your function. Your c value is a horizontal translation. It'll move to the left if your c value is positive and right if it's negative. And if you notice here, your c value is your value being added after you've factored out whatever is in front of the x. Finally, d would be a vertical translation. Up if your d value is positive, down if it's negative. And y equals d would be your midline. So if d was 3, then you would take your function and your midline would be 3. So if it was sine, it would go up from there and then down, up. So that's what d would do to your function. So some real-world applications for this would be if you want to figure out the height of a tide at a specific time of day, or the motion of a Ferris wheel, how high you're going to be after a certain amount of time, or anything with periodic motion. So any sort of motion that repeats itself in equal intervals of time. So with a Ferris wheel, for example, your height would be this value when you start, and then your height would increase until it hits the top, and then your height would decrease all the way back to where you start. So we'll have a problem with this later on in the PowerPoint. So here we have our first IB practice question. It says, graph at least one full period of the function -3 cosine of 2x plus pi over 4 minus 1. So the first thing we'd want to do is factor out whatever is in front of our x. So this would become -3 cosine of 2 times x plus pi over 8 minus 1. So now we want to know what our amplitude is, what our period is, our horizontal shift, and any vertical shifts. We also want to know if we have any reflections. So our first thing here is the negative. So the negative in front means that we have a reflection over our x-axis. And that's because it takes all of our positive y values and then flips them to be negative. The next number we have is 3, and the number out in front will be our vertical stretch, and since it's a 3, that means our amplitude is now 3 instead of 1. The 2 here means we have a horizontal stretch by a factor of 1 over 2, so our period is 2 pi over our b value, so 2 pi over 2, which would just simplify to pi. For a horizontal shift, we have plus pi over 8, which means it would be left pi over 8. For a vertical shift, we have minus 1, so it would be down 1. So now we can go ahead and graph this. So it's been shifted left pi over 8, and our vertical shift is down 1. So our midline is going to be at -1. So this is where our midline will be. Our period is pi. So we want to label this so that we have a full period in here. So we have pi over 8, which is negative. Then we have 0 pi over 8, 1 pi over 8, 2 pi over 8, 3 pi over 8, 4 pi, 5, 6, 7, 8 pi over 8. So this is pi here. And then here's pi over 2, pi over 4, 3 pi over 4, 3 pi over 8, 5 pi over 8, and 7 pi over 8. So a full period will be from negative pi over 8 to 7 pi over 8. So now we need to figure out our starting point. Typically, your cosine function would start at +1 on our y-axis. It's been shifted left pi over 8, reflected across our x-axis, and then our amplitude is 3. So it's going to actually be at -4. And then our maximum will be at 2 because that'll be 3 up from -1. So to draw your function, it's going to complete an entire cycle over pi. So it'll be back down to -4 at 7 pi over 8. Halfway through, it'll be at its maximum. So at 3 pi over 8, it'll be at +2. And then halfway between those values will be when it hits the midline. So here at pi over 8 and 5 pi over 8. So then you can draw your function. So it'll go up, hit its peak value, and then come back down. So this is how you would sketch your function given here. Now we have our second IB practice question, which is also no calculator. It says, Sarah and Dylan are going to ride a 100-foot tall Ferris wheel. They get on the Ferris wheel at the lowest point, which is the loading zone 10 feet off the ground. It takes 12 minutes to ride around the Ferris wheel once. Draw a graph of their height versus the time they've been on the Ferris wheel. So we have a Ferris wheel here. It says it's 100 feet tall. They get on the Ferris wheel at the lowest point, so they'll get on here, which is the loading zone that's 10 feet off the ground. So they have a loading zone here, and that's 10 feet. It takes 12 minutes to ride around the Ferris wheel. So now we can draw a graph. So when we have our time, when they start at time 0, they're going to be at 10 feet. It takes 12 minutes to complete the circle. So after 12 minutes, they'll be back at their height of 10 feet. Halfway through, they'll be at the maximum height. So after 6 minutes, they'll be at the height of 110 because it's this 10 plus the 100. So at 6 minutes, they're at 110 feet. And at the halfway points, they'll be halfway through that. So at 3, they'll be halfway between 10 and 110. So they'll be at 60 feet. So at 3, they'll be at 60 feet. And then at 9 again, they'll be at 60 feet. So your function's going to look something like this. So this would be a graph of their height versus time on the Ferris wheel. We can also come up with our function for this. So f of x equals, if we look here, our midline will be at 60 feet. Our amplitude is going to be the distance from here to here, which is 50 feet. The period is 12 minutes because that's how long it takes to complete a cycle. And we'll use the cosine function because we're starting at either a maximum or a minimum. And since it's minimum, we're going to reflect it across our x-axis. So first we'll start with our reflection. So it'll be negative, and then our amplitude, 50, times the cosine. We haven't shifted it left or right at all because we're assuming we're starting here. But we need our b value. So our period equals 2 pi over b. And since our period is 12, we know that 12 equals 2 pi over b. If you multiply by b and then divide by 12, you'll get that b equals, we'll simplify this to 1 and 6, so it'll be pi over 6. So we have cosine of pi over 6 times x, and then our midline is at 60, so we'll say plus 60. So this would be the function that describes the motion of the Ferris wheel, where x would be your time in minutes, and f of x is your height in feet. So they don't ask for the function here, but if they were to ask for the function, you would need to do that. This one, they just ask for a graph, so this is what you would need. So in summary, our sine function has a y-intercept of 0, 0, an amplitude of 1, a period of 2 pi, and it starts by going up from your y-intercept. Our cosine function has a y-intercept of 0, 1, an amplitude of 1, a period of 2 pi, and starts by going down from your y-intercept. Your tangent function has a y-intercept of 0, 0, a period of pi, and starts by going up. It has vertical asymptotes at x equals pi over 2 plus pi times every n. So every pi, 2 pi, negative pi, you'll have another asymptote. For transformations, f of x equals a sine of bx plus c plus d, where a is the amplitude, 2 pi over b is the period, negative c is the horizontal translation, and d is the vertical translation. And all of this can be applied to different things such as ocean tides, Ferris wheels, and periodic motion. That's all for this video. Thank you for watching.